Good morning, good afternoon, good evening. My name is Matt Clausen. Today I'm here with Arthur Hicken to talk about 5 imperatives for delivering software with confidence. I'm going to introduce Arthur a little bit more formally in a minute, but let's talk a little bit about the agenda for today. And just before I get into the agenda, we will, of course, this is being recorded, it's on Bright Talk. Obviously, you'll get links to the replay. In addition, uh, the slides could be made available, so you can always reach out to us, and we can make slides available on request in many instances, PDF version, and so that's also available. We will do Q&A at the end, so of course you use the standard Bright Talk Q&A. Type in your questions, and we'll get to that. And so with that, I'm just checking to see if we already have questions, but of course it would probably be like, can I get these slides? Is there a recording? Is there going to be Q&A? Anyway, all right. So that's kind of a funny question. Is there going to be Q&A? You're asking a question. All right. Anyway, but here we go. The agenda. So we're going to start with a brief history of software delivery, uncertainty, and doubt. If you've been in the software industry for any time period, you may be completely I don't want to say immune, but you may be completely desensitized already about it. When you actually think about, software versus maybe some other engineering disciplines and what we put up with, and what we kind of allow, it's pretty crazy. There's some good reasons for it, right? Obviously, we all, if you know anything about software, but we're going to talk a little bit about that. We're then going to introduce, what does it really mean to deliver software with confidence, and what are we talking about? Because there could go a lot of different directions. So I'm going to kind of put that into context, and then we're going to get into our discussion of the 5 imperatives for delivering with confidence. And these, by the way, it's not like, hey, Arthur and I, made these up. Although we did have a discussion and brainstorm and had a longer list and said, hey, what are the right 5 things, the most important 5 things? But really, these are things that we observe in the market. We observe from our customers that are most successful. These are the things that seem to be sort of turning the dial, sort of, improving, maybe, allowing you software development directors, managers, leads, to get a few more hours of sleep every night, or I should say minutes of sleep, maybe not hours. Maybe we're not delivering that much confidence, but definitely improve, right, the level of confidence you have as you develop and deliver software in a more continuous fashion. So that's the quick agenda, and I'm going to do the intro, and then I'm going to pull Arthur in to the discussion. So first, a brief history of software delivery, uncertainty, and doubt. So we started with, again, there were other methodologies out there, but we're all probably familiar with this idea of a waterfall methodology. Again, if you've been in the realm, maybe you've even experienced it, and it just exudes confidence, right? That we are going to be able to deliver what we say, and so it's not that every project failed, right? I think it was the Standish Group put out reports year on year on year about software sort of delivery woes, and confidence levels, and so bottom line is, waterfall was not the best methodology for software because it was missing some key components of some of the differences between software and other engineering disciplines. And I was going to tell a story here. I think, for time's sake, I'm not going to tell the story, but there's a really interesting story about some monks having a discussion about building bridge building versus building software, and it's pretty interesting, little story. You could probably even Google it, but definitely, software is not like other methodologies for a lot of good reasons. And so, really out of necessity, sort of agile came into being, right? I think there were some really, really smart individuals sort of observing some of these challenges and woes and said, there's got to be a better way. There's got to be, we have to be able to do something, um, and, different, right? And there was a lot of cultural issues with making this change through the years, but it has become the de facto standard, right? Today, in fact, I'll talk a little bit more about that. But agile or agile like methods and processes really have affected everything we do in software. Um, all modern software development is in some way shaped by some of these concepts, right? That started with this Agile manifesto. What's interesting is as you read these things, right, it doesn't talk necessarily about, talks about these concepts and what we value over these things, right? Individuals' interactions or processes. Not that the others aren't, there isn't value on the things on the right, but of course we value things on the left more, right? But there's a few things. First of all, collaboration, um, actual demonstrable software, right? Responding to change makes you think about this as being very iterative and incremental. And I think that's, people observed this in the 90s significantly, that teams that took a more incremental, iterative, incremental approach did have more success. Were able to sort of meet the mark. Part of the problem is, of course, the mark is changing as you go, right? So this was a good effort, right? It's shaped how we do software today. And so, of course, we're all really bored at this point, right? Because it's just so predictable. Our software delivery is so predictable because we've gone to this model um, that has us going in loops, and but obviously I did this to be a little bit funny because it is getting better, but I would suggest most of us are still in the situation where we're like, no, it's not really boring in that sense, that this is very predictable um, in terms of how we deliver software. And so there's more, there's room for improvement, let's say, and in terms of our ability to deliver on time, with the right quality levels, et cetera. We'll talk about those in a minute. What my definition is of confidence and what we have confidence in. So just a few stats though about where we are. I think there's some interesting tidbits here. So one, quality is absolutely improving, but it's really interesting, right? So there's a state of software report. I should have put the source here. I apologize. So there's a state of software report that comes out annually, and I think EMA is a company that puts it out. And what's interesting is when they polled and said, what methodologies are your teams using? And then they looked at laggards, sort of the average or mid range in terms of quality, and then quality leaders. Okay. What they found is quality leaders, right, were pretty much 100% of them were using modern DevOps, Agile, and CI/CD practices on their projects. Okay, and the number and the percentage went down significantly with laggards in quality laggards. Okay, which is really interesting because early on in Agile, when we were doing survey work about what's the biggest value you're getting moving to Agile, we were expecting speed of delivery or whatever, but it was like actually quality, right? Because of the demonstrable software piece, like every sprint. And so we're finding bugs earlier, defects. We're finding, obviously it's also about requirements, meeting the requirements. So we're finding things earlier and we're trying to fix them. And then this whole notion of hardening sprints came in and other things, right? This whole idea of technical debt and percentages on how much we're working on new features versus other defects and so forth. And so quality became a focus in this and benefited significantly. So that's no surprise. But there's an interesting thing is there's this gap, this huge gap between these leaders and laggards as you ask these questions. And here are some of the key areas where there was the biggest gap. I thought this was interesting. So one, practices of requirements management, test management. And test management, by the way, I think encompasses the whole notion of formalized testing, as well as managing, developing and managing requirements. The leaders in quality, right, focused the biggest gap of all the different managements across the board that you could think of in software, and there was about 10 listed. These two were the two where there was the biggest difference between leaders and laggards. Okay, kind of comes back to kind of 101, right? Requirements are still important, right? And then, by the way, we have to validate and verify that the system, right, is doing what we said it's going to do. And so embedded software quality resources inside dev teams, not embedded software, but the quality resources being embedded inside of the development team as an artifact or a part of that group is a big differential. The use of automation across CI/CD pipeline in practically every testing tool category was a pretty big gap between the laggards and leaders. Leaders were automating much more. And then also they talked about shifting left in quality practices was a big gap between the leaders. And then finally, okay, to some of you this is a bad word, right? Standards, if you're a developer anyway, it's maybe a bad word for you, but the use of quality standards such as ISO actually have been adopted much more significantly by leaders than laggards, which I find interesting as well. And of course, that would probably vary a little bit based on your type of software and industry and so forth. But anyway, so all right, so let's get into what are we talking about. So first of all, confidence. Let's define confidence: a feeling or belief that you can do something well or succeed at something. Wouldn't we like that? That was part of our job, our main part of our job. Wouldn't we like to achieve that? And then what are we talking about? Confidence in what? Confidence in what? We're talking confidence in quality, compliance, safety, and security. These are the dimensions that I want to talk about. So these are all important. They actually each have sort of distinct definitions and aspects. And so each of them is, I think, really important. So we're going to talk about those things today somewhat in our discussion. So what are the 5 imperatives? So we're learning this, right? We're observing this. Some of these are fairly obvious, but so CI/CD and DevOps are really good, right? We see a huge value in those practices and the tool chains, but we have to do better at integrating quality processes and tools into those, both the process aspect, practice aspect, and the tool chain. Sorry, I apologize. I'm going to close my door here. I have a barking dog. And then shift left. I just mentioned shift left. We're going to talk about that. Some of you probably know what that means, and some maybe not as much. But thinking about quality testing earlier in the process, right? Thinking about how do we intercept and potential issues earlier, again via practices, tools, process, etc. There's a whole lot to that. And then smart automation. So use of intelligent automation, maybe AI. In this case, we're going to talk a little bit of AI. It's 2022. We should be able to apply that somehow. Compliance, is important, and specifically here we're going to focus on security. Security is paramount. When you look at challenges and problems listed, security challenges continue to be top of the list, depending upon who you're talking to within the technology realm. But definitely security, we continue to see that. Safety, obviously, in the embedded market, where we have smart, connected software-defined vehicles and so forth. And then finally, I think one of the areas that's overlooked a lot of times in the realm of testing, especially in quality, is the environment as a whole. We are developing these applications that literally are dependent on hundreds of other services and APIs and databases. And we expect that we can just somehow magically develop this application in a bubble and then test it in a bubble and deploy it, and it's going to work. It's like, well, wait a minute. The whole function of this thing is dependent on all these other systems, and it actually creates a ton of complexity in managing that testing environment. So we'll talk about that a little bit. So those are the areas. So now let's bring Arthur into this discussion. So Arthur, known as Code Curmudgeon Hicken, is our evangelist at Parasoft, and we're very, there you go, very good. Yeah, so thanks for joining us today, Arthur. It's going to be an excellent, I think, conversation. And so good news is you get to hear somebody who's much more expert than I am talk most of the rest of this time. So let's queue up the discussion. So integrating quality into CI/CD and DevOps is critical. And this is an interesting. I purposely, this looks kind of kludgy, this diagram. I kind of did it on purpose. Those of us that are in quality and testing, right? We kind of think about this testing pyramid, and yet when we really think about how development is done, we more think about either that infinity diagram version of this or the pipeline version of this CI/CD diagram or DevOps diagram in terms of a pipeline. But Arthur, does this even make sense? This diagram, and does the pyramid still apply? And
I've always liked the pipeline because it implies, like a software factory or something, right? Like it's a set of steps that you can understand in every other form of engineering, right? Like we're going to start over here and we're going to end up over there. And it occurred to me when you were talking a moment ago about like CI/CD and DevOps are good, right? And it's funny because I normally think about them as a challenge, right? Like this is going to make your life harder. But then I thought, imagine that, you stepped back into, 1965 into an automotive factory anywhere on the planet and said, we're going to have to produce cars twice as fast. And you just went over to the assembly line and turned the dial to 2x. Now, there'd be two things that happened. One would be that lots of stuff would smash into other stuff. And the second thing would be that at that speed, you'd figure out what all the problems were and you'd solve them. Whereas at slow speed, you might not have noticed that this was a problem. And I think in software that the small a agile movement, let's take little pieces and crank them out and get them well defined, and then start cranking them faster with this continuous, meaning, hey, we're building constantly. We're not building once a week or once a month or at the end of the release. We're building not even just hourly. We're building when you check in. We've cranked that speed dial up and we found all the things that broke in it. And I think what you see in your difference between leaders and laggards is those who've tried to accelerate smashed their assembly line and fixed it versus those who are running the assembly line slow going, I can't speed it up. I can't speed it up. And that's where that confidence comes in. The pyramid, I had this love-hate relationship with the pyramid. I almost want to start a drinking game. Like, no offense to the people who developed the pyramid, but it's like when you see the testing pyramid, like take a drink, and in some conversations you'll get drunk really fast. The pyramid has a really cool, useful purpose.
But that could be a motivator for some people, Arthur, right? So is that a motivator or
software while drinking? Yeah, that's a great idea, especially when you want confidence. Yeah, the interesting thing about the pyramid is the pyramid was there to help us understand automation quantitatively, right? Like things at the top of the pyramid are messy, and so you don't want to, you want to minimize them. Things at the bottom work well in small little chunks and can be automated well, so you want to do a lot of them. But then we started talking about stuff like, you've been tossing out the phrase shift left, and on a pyramid that doesn't really mean anything, right? Like I could be sliding down the side if I'm shifting left, right? And so you drop your pyramid on the side, and I do think it's interesting because the shift left movement, let's call it test early, right? Today, here and now, let's put our foot down and say test early, not shift left. It's been demonstrated that if you test early, then it's not just that you find the bug before you release, but the cost of finding the bug is much cheaper. And because it's closer to your brain at the moment that you created the code, the cost of eliminating the bug is much cheaper. So like the earlier that you can, do something, the better off you are than letting it run till, midnight of the day before the release, right? Like that's kind of the thing. So I feel like the pyramid, sometimes the metaphor is overused. I think it has a value, but in the pipeline's perspective, its value is just telling us, hey, small pieces, right? I mean, that's the nature of agile, little pieces, right?
Yep.
Early and often.
So here's the $1 million question. Where does the pyramid come out of that single test step, or does the pyramid apply more uniformly across other steps, or what is your opinion?
S- So the principles in the pyramid, like if you look at that top of the pyramid, it's hard to tell its side. It looks like a bowling pin, but that's a human, right?
Yep,
In your
yep,
top
manual.
triangle.
Yep.
And it's like avoid humans. And I have literally been at organizations where there was a step in the build process and somebody like stuck something on a USB drive and walked to another system, right? Or somebody said, "Well, it's no big deal. It's highly automated, but at this moment, I have to click this thing in a UI, right, to kick it off." And even not just click to respond, but like even a click to kick off means that I can't do it every time someone checks in the code. So
Yep.
yeah, the lack of reliance on a human step. I want to get the human away from being test execution. I want them to be not test creation, but test design, right?
Yep. Yep. Yep.
And test
Exactly.
remediation to some degree, but like selecting how do I do what I do and when do I do it? And those thoughts should carry throughout all this. If you start in testing, you've got three more steps to your left, right?
Yep. Exactly. Yeah. So that's actually a very good segue to the next one, which was, I talked a little bit shift left, but really, focusing on code quality. So creating automated quality gates and standards compliance. Call those gates as well. I mean, you can, make, but here's the deal, right? I think it's shown, right? If this isn't automated, it's not easy for developers, right? I was a developer way, 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 way long time ago. So I can say, hey, inherently, I wouldn't say developers are lazy, but when it comes to, there's some bad words in the world of development, and that people, it's like it's a creative thing. People that are really good at development, most people do not like the word standard or compliance or testing um, a whole lot. But as a result, we kind of have to make it easy. So talk a little about this diagram, um, and I think you know hopefully hopefully people recognize something like this. But can you talk a little bit about this?
Yeah, I got a couple things. So one is I do want to say because you've brought it up a couple of times now, the evil S word, right? The the standards word. And I'm just going to give a challenge to those of you that are watching this. You cannot call yourself a software engineer and think that standards is a bad word. I'm sorry, it's just not possible, right? You won't go to an electrical engineer who will argue with you about the standards, right? You won't go to a mechanical engineer who will argue with you about the standards. Standards doesn't mean a bunch of stuff that annoys me. It's the embodification of best principles that allow us not just to test early and often, which is what we were talking about a moment ago, but allow me to build something better in the first place. We have to start producing less mess. Otherwise, when you speed it up, it's a traffic jam. I guess I should have asked you to put the Lucy and Ethel chocolate assembly line in here, right? Like we probably all seen it. If not, like send us a thing and we'll send you a link, right? But they're like trying to pull the chocolates off the assembly line into a box, and at some point the assembly line speeds up, and pretty soon they're throwing them into their mouth. It's what happens when you speed the system up. This is cool. Here's a nice little like, here's what we're doing, and I think there's another interesting thing about quality here, Matt, is that like 15 or 20 years ago, from a messaging perspective, like quality was a bad word. Like no one cared. I don't want to say people didn't want to build quality, but quality wasn't people's primary focus. And we care again now. And I love
Yep.
that
Yep.
quality is something that when I talk to organizations, to developers, to testers, that they actually care. And I feel like this short feedback loop, we've got an automated system. I have a piece that I'm working on. It's tiny, so I can get an answer. I get an answer fairly quickly. and kind of a hammer carrot thing, right? Like I can either, get my push accepted or not accepted, right? But I get this
Right.
feedback,
Yep.
and so it like quality is easier for me to understand than it is if I'm only writing code,
Yep.
right? When I see everything.
Yeah. I wonder, because I think when I think back to when I was part of development teams, and you start thinking about like quality, you start thinking like Six Sigma, right? And I'm like, that kind of quality, like it's almost like in what was it, office space, or where was the efficiency experts come in or whatever. But it's these guys, these guys with this extreme, with it felt like a big sledgehammer, man. It was like, okay, we're looking for a gnat here, man. We probably don't need a nuclear weapon to go after that. And so I think that's part of it was this overkill, because it was, again, at the time, it meant a lot of manual extra work, right? What we're talking about here is not that. We're talking about, like, if you can't automate it, you should probably need to rethink it a little bit in terms of this is kind of, it's almost like it's just, it has to just be automatic, right? Like you said, even an extra click could create a problem here. But I think that's the key, right? So that little laptop at the bottom is this, the world of this developer, and the idea is they shouldn't have to go outside, even outside their IDE in most instances. Yeah, maybe maybe they do go. I mean, look, every developer probably is going to go into some, GitHub, GitLab, some other cloud-based environment these days, to do some work. But a lot of that is even, kind of integrated right into their IDE. So I think this is a big one. And let's talk about what are the gates though here. So we talked about, we're talking about testing and quality, but what are we talking about when we say gates or code quality?
That
Because it's not just one size fits all necessarily either, right?
that is the right question, and this is again the funny thing about quality because it in those Six Sigma, and I don't want to denigrate Six Sigma, it's not part of the software process, right? But in those days where it felt heavy, we felt like, well, with software, I can't define what quality is, therefore I can't put up any form of measurements. A gate is just a measurement, right? I've set a policy that says I'm not going to allow this kind of thing, or this kind of thing must be there, and I'm going to move my software on. And the interesting thing is that the gates are really your personal policy, your implementation of your policy that says, hey, we expect people to do thorough unit testing. Therefore, I will look at coverage, right? Therefore, I will look at the number of failures in the test suite. Ask yourself right now, like the honest question, do you know what the coverage in your testing is? If not, you've got some room for improvement. And ask yourself, do you have tests that fail as a regular part of your quality, right? Can Is your gate clean, or is it like this really funny thing with all these funny exceptions, right? Like we have this test suite, and as long as it hits 90% you know, test success, it's okay. It's the gates tell me what I'm okay with and what I'm not okay with. And it's not 100%, right? It's not, we can't afford perfect software. I wish we could, but the gates help me define whether it's coding standards, whether it's coverage, whether it's various metrics, whether it's performance of the code, whatever the criteria. If you or I were looking at the software and the results of the testing team, and we would say good enough or not good enough, and those become gates, real measurements, not arbitrary decisions where you know we hope that Matt's there today because Matt will let you slide on, coverage, right?
Exactly. Um, all right, so let's move on. Let's move on to our next topic here, or our next imperative, which is smart test automation. So I think we talked about automation, but I think and we talked about, the concept of creation, execution, and we didn't talk about maintenance really a whole lot yet. So we start talking about automation. There's some issues with automation, right? And I think there's, I think there used to be a heuristic. I remember back in the days when I sold automated testing software a long time ago. I guess I was like a technical person on a sales team, and I would demonstrate it and so forth. We would talk about this 5x, like the first time you develop a test, it would take 5 times longer than if you were just going to execute it manually to script this thing out. But it depended on how many times you're going to execute it and how volatile the application was, et cetera, in terms of regression testing. And then there's a formula, right? You could kind of apply and say, hey, what's the ROI here? And but the point is, there's actually smarter ways to both create, right, using AI, and to create, execute, and maintain tests these days. And again, it varies widely from API testing to UI testing to static code analysis as to how you would apply AI. But let's talk about that a little bit. Can you talk a little bit about some of the cool AI stuff that can be applied in the world of testing quality?
Yeah, obviously test creation always falls first, right? Because it takes a long time to build up a full test suite, and part of the building up the test suite is building up all of the ecosystem that you need and the infrastructure that you need. And then part of it is like really stupid, tedious stuff, right? Like there's basic cases that you can intuit from looking at the code or from the UI. And then part of test creation is understanding the business logic and making something realistic happen. Or, especially when you get into safety and security, thinking about abuse cases and going, how can I screw this up, right? That's really the fun tester job, in my opinion. I know that every tester has their own thing that gets them excited. I like breaking stuff, right? So test creation is where you start, and it was obviously the low-hanging fruit for automation because there is so much tedious work involved that lends itself well toward automation and that people don't like, so they're happy to have it. We started doing that back in the 90s with unit test creation, right? Like we read the code and create all the sort of basic boundary tests that you could do, and then apply some simplistic breaker knowledge to see if you could make something bad happen. And what happens is once you do this, your number of tests goes way, way up. Now you start to ask yourself two different things. And I actually probably would put these two in a different order, your execution and maintenance. So I'm going to take them in a different order, Matt. Your next thing is like, how long is this test going to sit around and what's going to cost me to keep it running? Right. And it's a question that we didn't used to ask. We were so focused on test creation that we would say, oh God, can I create a test? And if I can, it's good. It's good that I can create it, rather than, is this a good test or a bad test? What effort will it take me to keep this test over the life cycle of this project? Right? The test doesn't live for the release. The test lives forever. Right? Tests
Yep.
don't
Yep.
die. And no one ever removes a test, right? And so tests start failing. And then you ask yourself, well, why does it fail? Well, the nature of testing based on a test suite is to look for the delta between what happened before and what happened now, right? What is the difference? And so if you fixed a bug in the software, one expects a test failure. That seems counterintuitive, right? Like I fixed it, we should get one less failure, but we might get one more because the old behavior was codified in the test suite. And sometimes I need to update the test, and sometimes I need to fix the code because I really broke something. And sometimes I look at the test and go, that's a bloody stupid test. I am sick of fixing it, right? And make the test go away or make it smarter or quieter. So I think, thinking about test maintenance and what it's going to cost has become really important. And this is where, again, like AI can help us create tests by looking at UI, by recording traffic. We can do it, at the code level, looking at the code and making suggestions. AI can also help us at the maintenance level when it starts to look at, either by, analyzing the tests or by looking at test executions and say, this thing's failing all the time. You probably picked a bad locator. You picked a bad assertion, right? And if you have a really good AI and it can look at other things like, if you're testing a web UI, it can look at other things, say, well, you selected something that said field 4 and it's really phone number. And so if we grab the phone number label, it'll be consistent whenever you add a new box to the field, it won't mess you up, right? Things like that kill you. So having an AI analyze, as a human, it's easy for me to say, oh, crud, the locator changed. But I might just pick another bad one and then another
Yep.
bad one.
Yep.
And
Right.
so the AI is really great at helping tell us, here's the thing that's proven to be stable. And then we get to execution, because at some point we all fall into the trap of measuring our success as a tester, not based on a quality measurement or a confidence measurement, but based on a quantity. I used AI to create a whole bunch of tests. Therefore, I've got 50,000 tests and I used to have 10,000 tests. 50,000 is better than 10,000. I don't know that it is. It might be worse, right? And one of the ways that it's worse, there's two ways. One is, does it produce more noise that you have to deal with? And does it produce better coverage? And how long does it take? Right?
Yep.
And
Yep.
so that's when you get into your next problem, that as projects grow, and you and I have talked a lot about cars over the last couple of years, right? And how they've grown from, you know, hundreds of thousands of lines of code not too long ago into tens, and we're pushing more and more models past the 100 million lines of code barrier, and they can't even fly, right? I mean, aircraft has a jet fighter can have 30 million lines of code and fly and shoot bombs, right? Which is
All
fine.
right.
But as that happens, you have more and more and more tests, and as the complexity builds up, you think about smart anything, right? Like connecting to the internet, connecting to APIs. You have more and more and more and more tests and more external dependencies. And if you can't know which test do I need to execute, the classic fear people have is looking at a small issue either right before release or that a customer reports and going, it's better to leave that than to fix it because I don't know what I'm going to break. That's another way of saying I have no confidence in my testing system, right? That's
Yep.
exactly what that is. So being able to execute the exact right tests, no more and no less, enough that I know it's working right, and few enough that I can do it quickly, is super, super important. And it takes an AI, again, monitoring the history of what's going on, understanding the flow of how the tests interact with the code, how the pieces of the system interact with each other. It's not enough if you have a function called, calculate space, to go run test calculate space. That calculate space might affect some user interaction deeper down, and you've got to go find all those tests. And so having an AI to help you pick, right sized testing, can we call it that, right? Like just enough
Yep.
testing is
Yep.
super, super important.
Yeah, I think look, I think the point is, you kind of covered the broad brush, obviously, of a lot of different ways AI can come into play. We offer obviously many of those things in our own tool set. We're not here to talk about that per se. So if you have questions about that, obviously you can ask those. Again, get in touch with us. Check out what we've got to offer. But one of the things that's cool goes back to the code quality, and you mentioned it sort of, but I just want to call it out, and that is, if you do static analysis, there's this notion of, like, false positives, because you can depending on what rules you turn on, right, in a code checker, right, static analysis tool, you can create, hundreds if not thousands of exceptions, and then figuring out, okay, where's the bang for the buck, in these, and which ones do I really care about, becomes really important, as well. And so I think AI, definitely can play a huge
And
role there. So, all right.
and I think just one more, Matt, is that,
Yep.
yeah, in that
Yep.
test creation phase, like when I think about the simple thing to do, it's super easy for me as a developer to sit inside of a browser and capture everything in a page and save it as a local test, right? Using HTTP unit or something, right? And now
Yep.
I have it.
Yep.
But if I look at all the stuff, imagine that I went to, pick your favorite shopping site and saved it, and it's loading your preferences and some ads and some news and some weather and some history and all of this stuff that's not necessary for my test. And that's one of those ways where, like the smartness, right? Like having the one of the classic examples that we do in demos frequently shows a shopping cart page, and you go in, and if you look, there's 40 API calls. But if you look at how many of these API calls are actually advancing the narrative, right? That they're on
Yep.
the path for the
Yep.
thing that I'm trying to,
Yep.
it's about 6.
Yep.
And so testing those 40 is giving you about 7 times the chances of having noise and false
Sure.
positives and,
Sure.
and having to
Sure.
deal with stuff
Yeah.
that doesn't matter.
Yep. It's true. And actually, another point. This is kind of a little different definition of smart, but if you try to execute those same tests via the UI, right, you could actually execute all 40 API
You'd
calls
have to.
in still a fraction of the time. Well, you'd have to in the UI, but you could still do it through API testing and still a fraction of the time than actually doing UI testing. So this is where smart means also the right kinds of tests, but that's not the AI smart we're talking about. But you
Yeah.
can use AI obviously in generating both at the same time if you have the right tool set as well. A single recording could generate both and reduce the noise, and do that on top of standardized frameworks like Selenium. So all right, cool. So let's move on. Security. Look, security is required. Period. Right. So here's where we introduce the second version of Arthur. Do you have your other hat with you? Your
Somewhere
sec
here.
dev, sec
That's in
test,
the other
sec
room.
ops, sec hat. But you know, um, so talk a little bit about security, and we do have to be a little bit cognizant of time. We're about 42 minutes in here, so we want to get to Q&A in a few minutes here. In a couple, probably 5 more minutes, 6 more minutes, get to Q&A, and we have one more after this. So yeah, but let's talk about security
So, I did this
testing.
little funny picture a while ago because there's this big thing. DevOps is a real thing, and it's, as you've said, it's a good thing. It's helping people, right? Like integrating the teams. And so somebody came along and said, "Hey, what about security?" And so we literally used to have these arguments at different like working groups about, is it DevSecOps or SecDevOps? And DevSecOps won, right? Like at some point it just became the most common phrase, so that's what we use. But like other people I've talked to still argue, well, no, security comes first. I said, well, it doesn't. It should permeate everything and surround everything. And that's why I'm sec dev, sec test, sec op, sec, right? Like security starts before you write the code and it continues once you've deployed. So as we start to move at speed and as we start to move from like CI to CD, meaning we're deploying stuff, we're automatically, without human intervention, making something go live. That thing better be secure, or you're opening your organization up to a world of hurt. And in an era where we have massive work from home and also shop from home and manage my life from home and handle repairs from home, everything's going online, and the chances that someone has at attacking your system are much greater. It's easier for them to attack, and they're more frequently doing it because the attackers are also working from home. So we have to always think about security, and it means that we have to start doing proper security behavior, which is not just, hey, test it, right? We have to pen test it. We have to start building applications that are fundamentally more secure. And that's, using static analysis and the dreaded S word, right? The coding standards
Yep.
that
Yep.
codify the best practices.
Yep. Yeah. I think it's again, people think about security, AST, right? SAST isn't necessarily the sexiest thing there, but I think it's a critical thing. And I know again, I think there's also quite a lot of tools to choose from. in that realm, and there is a difference. A lot of times, kind of that adage of you get what you pay for does apply a little bit, because now you think about, okay, well, we have to have this, again, go back to this whole notion of, automating that entire tool chain. If you can do more, if you can hit compliance, security, other quality gates, with a single tool, for instance, or tool set, that feeds back into some sort of a quality dashboard that then allows you maybe to do some unit testing and code coverage analysis. I think there is value there, because your whole job. I mean, I've been part of these conversations over the last few years. Like the tool chain, like if you just go with a pure best of breed. And by the way, the leaders in that security survey that I talked about earlier, one other area where the leaders were quite different than the laggards was the leaders did not just pick and choose best of breed in every instance. They actually relied on more suites and platforms, tools that could do a little bit more for them. Being smart about that and how that could integrate into their tool change, I thought was interesting. And anyway, so I think it is important to sort of think about that as well. So security is not an island unto itself. It's super important, but it could be integrated with other quality practices. In fact, one former CISO told me end-to-end testing is security testing, because he's like, if people actually did it and they actually thought about it, security, would actually improve. Vulnerabilities would go down. So, all right, last conversation, last piece. So this is about taking control of the test environment, right? And so in this case, we're just going to call it out. Leaders use data and service virtualization, period. If they're developing anything remotely like a modern web-based cloud application that takes advantage of services and APIs and data and all this other stuff, we've had some of our customers actually call their environment untestable, right? This is untestable without service virtualization or data virtualization, right? It was, right? Because doing it manually or just using stubs or do certain kinds of mocking but manually, right, just didn't scale. So talk a little bit about this, and then we'll get to Q&A. So
yeah, I was going to give like a really short definition of service virtualization, because people often think, oh, well, that's not what I'm looking for. I view it simply as a way to decouple yourself from something that makes it painful to test, right? Is there a database? Is there, you're trying to connect to PayPal and test if $1 million transactions get bounced? That's kind of a horrible thing to do, right? Service virtualization coupled with test data lets you do, you might think it's mocks or stubs. It's like stub plus, right? Like it lets me cut the cord to the particular dependency, whether it's a function, whether it's a third party, whether it's a physical device. I cut the cord, and then I make the thing at the end of the cord that I've cut behave the way I want it to behave. So it can allow me to test without that dependency on a particular thing. And it can let me put the thing in a very specific state so that I can check, too much data, not enough data, too fast, not fast enough. I can isolate various components. So service virtualization it's a funny old telecom term, but these days it's a fancy way to say, hey, cut the cord, get yourself decoupled from all of these things that make your system hard to test and make it hard to remediate. Because again, in testing, we usually, we're doing big end-to-end tests, and the database guys are like, no, it was the network guys are like, hey, it was the UI, and the UI guys are like, hey, it was the database, and you're trying to figure it out. Once you start decoupling, you can tell exactly who's slow, right? You find your problem, You isolate your problem, you test faster, you test cheaper, you test earlier, you test more thoroughly. And that test data piece, right, and the environment piece, they all come together. I need to pull the plug, stand up a fake piece. I need data to feed that fake piece, and I need to manage the coupling of a set of pieces that let me test the particular scenario I want to test. Like today, I want to check Safari on a Mac running the old OS. Next, I want to test, Edge on Microsoft running Windows 10, now Windows 11, now with Firefox, like all these various ways that you can assemble the little pieces for your test are also a critical piece. So, data and decoupling the service itself, the stub, the mock, the proxy, and managing that whole thing all once together lets you test effectively. And in many cases, like you said, test something that you thought you couldn't test.
Yep. Makes sense. Okay. I think that brings us to a really good place here. Good conversation, but let's get to some questions. And so the first one is actually about the topic we were just sort of talking about briefly, which is how do you quantify the ROI of service virtualization? Actually, I'm going to decouple this. The question is really two things. Let's just talk about service virtualization first.
Yeah. So on one hand, you might say, if I could test something that I couldn't test, there's some value there based on probably defect escape rate, right? Something that I should, a way to measure my confidence. On another, it might be the performance of the test or the costs of the test. Because again, if I'm using a mainframe or a third-party service, the service virtualization can really help there. It also should affect your timeline for testing, because service virtualization is really lightweight and it allows teams to move independently rather than, okay, Matt's team can use the database, then Arthur's team can use the database, and now, Europe can use the database, and then Asia can use the database. We no longer have these sort of, swim lane conflicts. So that's another way to measure the ROI.
I think I'll mention one other thing. So as you guys, think about this, service virtualization is one of those things where you get huge scale and ROI when you centralize. Think of it as like a service being provided by some team that's for developers and development teams, right? So if you start thinking about an ecosystem by which many apps are being, developed, right? It's pretty common. There's going to be these common services or common databases that are going to be hit by multiple different applications. And so as you start thinking about, okay, how would we centralize that service of service virtualization and data virtualization, and who could maintain it? Again, you start getting, I think a better ROI, because now dev teams don't even have to worry about, they can put in a request for new services, et cetera, ahead of time. Boom, those show up as a service to them, right? As they go to test in their environment. So I think,
and I want to add to that, Matt, right? Because you said the dreaded centralized word. And so now it sounds like I have to go to IT and have them stand up an environment for me, which is what happens when you use hardware virtualization, like a VMware. With service virtualization, yeah, there's a centralized repository that says, hey, here's our login mechanism, here's our authentication mechanism, here's our credit card mechanism, here's our shopping cart mechanism. But from a developer or tester perspective, these are self-service, right? And they're exactly lightweight, and we talk about like deploy and destroy, right? You grab them, you set them up, and you throw them away, unlike the database where I have to populate it and clean it up when I'm done, right?
Yep. All right, let's move to one or two more questions. One I like, which is so move to another topic. We have a few more on this topic, but let's go to one on security. So and this is a bit of a loaded question, but are there any specific security guidelines you recommend using for best practices, right? So there's a whole bunch out there, right? CWE, OWASP, et cetera, CERT, but you can get lost in that world as well. So if somebody's just kind of getting started thinking about security, what do you recommend?
Yeah, so sometimes the guidelines are defined by the world you're in, right? So if you're taking credit cards, you have to do PCI DSS standard, for example. So take that into account. But yeah, if you're uncomfortable with security, if you're just starting to add it, if you're struggling with it, OWASP is great because it's free, it's open, and it's designed to be a beginner's standard. So it's a great place to start, right? You take the top 10, and OWASP has added, it's a less formal, less official project, but they have the top 10, which is, issues with web applications, but now they have an API top 10 as well. And so where we're starting to think and worry about API security and have a lack of confidence in it, they have a secondary set there. And the behaviors that you need to do and the things that you do to secure your APIs aren't fundamentally different. So it won't really add to your burden. It's an awareness issue. So I think OWASP is a great place to start. When you've done those top 10 and you're ready to move on, then CWE has a top 25 and they really have a top 40, and then they really have about 800 other things when you get there. If you're doing something in the engineering world, CERT is just a great place to be as well.
Okay, that's good. That's good. All right, last question. These are good questions, by the way, and I'm kind of cherry picking some that are about proof of confidence. So here's another one along those lines, which is, what are the key metrics to use for code quality, specifically going back to that code quality topic?
We do have another presentation I did all on which metrics mean what, right, on our YouTube channel. But yeah, the coverage, right? Coverage is not a good measure of quality, but coverage is a great predictor of lack of quality. So coverage is something I think about. Defect escape rate, am I letting stuff through? Is this whole testing system I put letting stuff fly through the system that shouldn't fly through? I think performance metrics, things should always be faster. Every version must be faster. I don't want to buy a new phone and it's slower than the old one, or a new computer, it's slower than the old one, right? Everything must always be faster, but performance changes are indicative of problems. So I do feel like performance is an issue. The number of failures that you're comfortable with slipping through the system, again, the number should be going down and not up. Right? So I think those are some real good ideas, but also how often is my test phase delaying my release phase? Am I releasing based on a date, or have I shifted to where I'm releasing based on I'm confident in my software? And to me, that's the real indicator.
Yep. So I think we missed one. I'm gonna close on this. Thank you so much, Arthur. And we kind of missed one thing. And I think we might have mentioned it here and there. Okay. So we gave you guys these 5 imperatives, but maybe there's one that's 0. If these are 1, 2, 3, 4, 5, there's a 0, which is defining what confidence means to you in terms of dimensions of quality, compliance, security, safety. If you don't have a well-defined definition of those things in your organization, what does that even mean? And you haven't thought through, okay, a practical, simple framework by which we're going to sort of, look at and apply. I think that's step one. It has nothing to do with tools, has nothing to do, but you're gonna find a lot more success. And by the way, that definition is gonna evolve, right? It's not gonna be static by any means. Obviously, you'll mature over time. So standards are a place to look. That's not what I'm talking about. I'm not talking about just we're gonna pick this standard. No, actually think about it. I think holistically is super important, and because then you can say, okay, hey, we've set the bar, and now confidence is based upon that bar to some degree. And if you don't have a bar, then how could you ever be confident, at all? So I think that's really important. So hey, thank you so much, Arthur. Any last words before we sign off for today?
No, I do think that we're in an era where we're moving faster, but I think that, as I've mentioned before, it hasn't necessarily made things worse. We have great tools now. We have AI beginning to take away tedious work and help us move to a new level. And we're seeing organizations do it in a very successful way. So, go be one of those organizations. Don't be a laggard.
Awesome. Yeah, exactly. Don't be a laggard. And on that note, you could probably learn a little bit more by looking at some of these resources or some QR codes. So at this point, you could just point your phone at the screen and pick up those QR codes to get right to some more resources. So we did a summit. We do a couple summits a year. One is on the embedded space, software space. So safety, security, critical, typically automotive, mil aero, med device, and others. And then we do another one, which you can see here, some of the logos, Cox Automotive, although that says automotive, but it's actually the more cloud-based mobile software, Woodman Life, RBC, Capital Services, AT&T, right? So all of those spoke. So what we do at these summits is, it's not Arthur and I up there speaking or other people smarter than me, in addition to Arthur from our team, but it's actually our customers talking about real world situations. And so that summit is really cool. And then of course, developing a business case for these types of things in terms of test automation is also, might be of interest as well for those starting out. So thank you again so much for your time. I think we're right at 1 hour. And for that, I'm going to say, hey, have a great day. Have a great evening. And thank you so much for your time today. Thanks, Arthur.
Thanks.
Yep.
Bye-bye.
Bye-bye.